Hi everybody, we are on Chapter 3, Section 2, Tides. Today we're going to learn about what causes tides, what affects the heights of tides, how are tides a source of energy. All right. You're standing on a riverbank in the town of St. John, New Brunswick in Canada. In the distance, there's a roaring sound. Suddenly, a waterfall twice your height thunders past. The surge of water rushes up the channel so fast that it almost looks as if a river is flowing back. The thundering wall of water is an everyday event at St. John. The town is located near where the St. John River enters the Bay of Fundy. An arm of the Atlantic Ocean, the Bay of Fundy is famous for its dramatic daily tides. When the tide comes in, fishing boats float on the water near the piers, but once the tide goes out, the boats are standing on a muddy harbor bottom. Okay? Causes tides. The daily rise and fall of Earth's waters on its coastlines are called tides. As the tide comes in, the level of water on the beaches rises gradually. When the water reaches its highest point, it is high tide. When the tide goes out, flowing back toward the sea. When the tide reaches its lowest point, it's called low tide. Unlike the surface waves you read about earlier, tides happen regularly no matter how the wind blows. Tides occur in all bodies of water. They are most noticeable in the oceans and large lakes. Okay, I'm going to move this right here. Okay, so gravity and tides. Tides are caused by the interaction of the Earth, the Moon, and the Sun. How can distant objects like the moon and sun influence water on Earth? The answer is gravity. Gravity is the force exerted by an object that pulls other objects towards it. Gravity keeps you and everything around you on Earth's surface. As the distance between objects increases, however, gravity's pull grows weaker. Figure 9 shows the effect of the Earth's gravity on the water on Earth's surface. The moon pulls on the water on the side of Earth closest to it more strongly than it pulls on the center of the Earth. This pull creates a bulge of water called a tidal bulge on the side of Earth facing the moon. The water farthest from the moon is pulled toward the moon less strongly than are the other parts of the Earth. This water farthest from the moon is left behind, forming a second bulge. In these places where there are tidal bulges, high tide is occurring along the coastlines. In the places between the bulges, low tide is occurring. Earth rotation through the tidal bulges causes most coastlines to experience 2 high tides and 2 low tides every 25 hours. So, let's look here. What causes, I'm going to move this in here. So, what causes the tides? The pull on the moon's gravity on Earth because the tidal bulges to form on the side closest to the moon and furthest from the moon. So there's a gravitational pull between the moon and the Earth here, okay? And this causes a bulge right here. Well, because everything's being pulled this way, there's not as much gravity over here, so it also creates a bulge right there. So where it's highlighted, that's where it is high tide. You see that there's not much water on these sides, so when the Earth rotates through this area, it is low tide. That's how we get high and low tide twice every 25 hours. Okay, so the daily tide cycle. Earth turns completely around once each day. People on or near the shore observe the daily tide cycle. As Earth turns completely around once each day, people on or near the shore observe the rise of tides as they reach the area of a tidal bulge. High tide occurs about every 12 hours and 25 minutes apart in any location. As Earth rotates, easternmost points pass through the area of tide bulge before points further to the west. Therefore, high tide occurs later the further west you travel along the coast. In some places, 2 high tides and 2 low tides are easy to observe each day, but in other places, the difference between high tide and low tide is less dramatic. One set of tides may even be so minimal that there appears to be only 1 high tide and 1 low tide per day. Several factors affect the height of the tide in a particular location. For example, certain landforms can interrupt the water's movement. A basin at the mouth of the river can also increase the differences between high and low tide, the speed and depth of water moving across as it flows into a narrower channel. That is what causes the dramatic tides in the mouth of the St. John River you read about earlier. The monthly tide cycle. Even though the sun is about 150 million kilometers from Earth, it is so massive that its gravity affects the tides. The sun pulls the water on the Earth's surface toward it. In Figure 11, we'll see that in a minute. You can follow the position of Earth, the Moon, and the Sun at different times during the month. Changes in the positions of Earth, the Moon, and the Sun affect the heights of the tides during a month. Twice a month, and the new moon and the full moon, the sun and moon are lined up. Their combined gravitational pull produces the greatest difference between the heights of high and low tide, called a spring tide. We're going to talk about that here in a minute. These tides get their names from the Old English word springen, which means to jump. At the first and third quarters, the sun and the moon pull at right angles. What's right angles? This arrangement produces a neap tide, which we'll talk about in a minute. A tide with the least amount of differences between low and high tide. During a neap tide, the sun's gravity pulls some of the water away from the tidal bulges facing the moon. This acts to even out the water level over the Earth's surface, decreasing the difference between high and low tides. So let's look at this. Okay, spring and neap tides are caused by the position of the Earth, the Moon, and the Sun. So beginning of week 1, we have a spring tide. At the time of the new moon, the sun, the moon, and the earth are aligned with the moon and earth and sun. The combined gravitational pull of the sun and the moon of Earth's waters increases the spring tide. So you can see we have a large spring tide, and that's because the sun, the moon, and the earth are all in a straight line, so it has the most gravitational pull here. Week 2 is a neap tide. At the time of the first quarter moon, the sun, the moon, and the earth form a right angle. The sun and the moon pull on Earth's waters in different directions, causing a neap tide. So you can see the tide is about the same all the way around the Earth. So it's a very low tide. So that's because we have the moon here pulling in this direction, and this sun is pulling in this direction. So it forms a right angle. So we have a lower tide, which is a neap tide. Then again on week 3, which is a spring tide, because now the earth, the moon, and the sun are all in one straight line here, and then we have bulges creating a large spring tide. Fourth quarter is a neap tide again, because again we have a right angle of the moon, the sun, and the earth form a right triangle, so you can see that all the tides are about the same. So there's not much of a tide difference between high tide and low tide, so it is called a neap tide. Okay, tide tables. Despite the complex factors affecting tides, scientists can predict tides quite accurately from many locations. They combine knowledge of the movement of the moon and earth with information about the shape of the coastline and other local conditions. If you live near the coast, your local newspaper probably publishes a tide table. Knowing the times and heights of tides is also important to sailors, marine scientists, people who fish, and coastal residents. Energy from tides. Figure 12. Can you almost hear the roar of the rushing water? The movement of huge amounts of water between high tide and low tide is a source of potential energy that is stored and can be used. Engineers have designed tidal power plants that capture some of this energy as the tide moves in and out. The first large-scale tidal tidal power plant was built in 1967 on the Rance River in northwestern France. As high tide swirls up the river, the plant's gates open so that the water flows into a basin, and as the tide retreats, the gates shut the trapped water. Gravity pulls the water back to the sea through tunnels. The energy of the water moving through the tunnels powers generators that produce electricity, just like the hydroelectric dam on a river. Although the tidal energy is a clean, renewable source of energy, it has several limitations. Harnessing tidal power is practically only where there is the largest difference between high tide and low tide, at least 4 or 5 meters. There are very few places in the world where such a large difference occurs. Daily tides also may not occur at the time when there is demand for electricity. However, tidal power can be a useful part of an overall plan to generate electricity that also includes other power sources between tides. Okay, homework for today is Section 2 assessment. I will see you again tomorrow. Have a good evening. Bye.